Assalamualaikum and good day everyone. I am Nurul Ellyana from Universiti Teknologi Petronas under Civil Engineering Department. So I'll be presenting on the utilization of spent garnet as partial replacement for fine aggregate in concrete. This is the content of my presentation. I will start with introduction of the project, followed by literature review, research methodology, result analysis and discussion, and it will end with conclusion. To begin, I will start with background of study. Basically, garnet is widely used in marine and oil and gas industry for abrasive blasting purposes. This creates a huge amount of spent garnet waste that are often disposed to the landfill. And this can cause high disposal costs and also environmental issues. At the same time, the construction also faces sand shortage due to over-extraction of natural river sand. Therefore, by using spent garnet as partial replacement for fine aggregate may provide a sustainable alternative for these two main issues. But there is a lack of comprehensive research on the effect of spent garnet by size and surface texture on the concrete performance. So for my project, there are two main problems, which is high volume of spent garnet from abrasive blasting purposes and also lack of alternative solution for fine aggregate. And this is the research gap, which is limited studies on the effect of particle size and surface texture on concrete's workability, mechanical properties, and durability for spent garnet concrete. And these are the objectives: to determine the physical and chemical properties of garnet and spent garnet size and surface texture, to evaluate the workability of fresh concrete incorporating garnet and spent garnet size and surface texture, and the last one, to assess the mechanical properties and durability of concrete using garnet and spent garnet size and surface texture. So the scope of work, I use garnet and spent garnet collected from shipyards abrasive blasting waste, and all the tests were conducted in UTP laboratory, including preliminary tests, fresh concrete tests, hardened concrete tests, and durability. So this is the content of my literature review. Here I have summarized key findings from the previous research that are relevant to my study and been categorized to 4 main areas. So the first one is physical properties. In physical properties, we discuss on the specific gravity. Basically, spent garnet has typically around 3.8 to 4.2 specific gravity based on this research study. And then for bulk density, it is generally higher than natural sand. And for particle shape and texture, mostly spent garnet has angular shape, but some of them have rounded shape due to the post-use. The second one is chemical composition. So from the table here, we can see the top three element is the major element in the spent garnet, which is iron oxide, silicon dioxide, and also aluminium oxide. The third one is mechanical and durability properties. So for the first one in mechanical properties, we have compressive strength and tensile strength. So in compressive strength and tensile strength, this research group have agreed that optimum value of spent garnet replacement is at 20% because it can give the optimal strength of the concrete, and above that it can reduce its strength. Same goes to water absorption for durability. For water absorption, when we replace 20% of spent garnet, can decrease the water absorption, and above that it can increase the water absorption by Ruslan in 2024. And the last one is challenges and opportunities in spent garnet utilization. So the challenges are impurities affect quality, inconsistency in particle size and shape, no standard guideline for spent garnet in construction, and the opportunities, it can enhance the mechanical properties of concrete, useful in fire-resistant and radiation shielding concrete, and also it can support sustainability and circular economy goals. That's all for my literature review. To conclude, what can I say is that most previous study only examine the use of spent garnet in general term without looking at the physical characteristic of spent garnet that can affect the concrete performance. My critical analysis can be confirmed or support by these two statements from previous research group from Jaffa 2020, Mokata 2021, and also Samsunawa in 2022. Moving on to methodology. So this is the flow of study of my project. I began with literature review and then followed by preliminary test for objective number 1. In preliminary test, we have SEM, EDX, ICPOES test, shift analysis of garnet and spent garnet, specific gravity of garnet and spent garnet. And during this phase, we want to look at the material characterization and all these tests, we followed American standard for self-analysis and specific gravity. And then moving on to the material, we have cement, sand, coarse aggregate, water, garnet, and spent garnet. And these are the details. So we target at 28 days, the compressive strength achieved 30 MPa. And these are the summary of mixed proportion of garnet and spent garnet concrete at 20% replacement. For sample preparation, each mix we have 3 samples, and for mixing process, all the materials were mixed using a mixer, and these are the mold sizes that I use, which is cube, cylinder 200 x 100, and cylinder 100 x 50. And for curing process, all the samples are cured for 7 and 28 days, and they undergo a dry curing method because we don't want any leaching of spent garnet or garnet during that process. And total sample, we have 45 samples, 27 cubes and 18 cylinder. Next, we move on to main test. For main test, we cover objective number 2 and objective number 3. Objective number 2, we did slump test. Objective number 3, we have compressive strength test, splitting tensile test, water exhaustion test, and also rapid chloride penetration test. So next is for result and discussion. The first one is we discuss on the physical properties. For physical properties, we conduct 3 tests, and the first one is SEM analysis. So based on this picture here, we can see garnet has angular, rough texture, which can promote better interlock and strength. And for the spent garnet, it has rounded and smoother texture, which can improve workability, but it will give less bonding. And for specific gravity, we can see from the result here, garnet and spent garnet have higher specific gravity compared to sand. It is because garnet-based product consists of iron aluminum silicate crystal, which contribute to its denser and heaviness. And for spent garnet, it has lower specific gravity compared to garnet because of the physical degradation of the post-use. And this table is the comparison of previous research and my research. And the third one is particle size distribution. So from the graph here, we can see the orange one is spent garnet, blue is garnet, and the green one is sand. And from this graph, we can see garnet and spent garnet curve lies above sand curve, showing that it is finer than sand. And for the spent garnet, it lies above garnet curve, showing that it is finest material among these 3 because of the surface degradation of the post-use. Next, moving on to chemical properties. So for chemical properties, we have EDX analysis and ICPOES analysis. For EDX analysis, we want to look at the chemical composition in garnet and spent garnet. And for the ICPOES analysis, we want to look at the chemical composition changes for spent garnet after mixing it in the concrete. And for EDX analysis, these are the results. And from the table here, the one that I highlighted in red is the major element consists in garnet and spent garnet. So it is confirmed that it is an L-bending garnet mentioned by Mutasha in 2018. And this element also contribute to its hardness, density, and chemical stability. And for the one that I highlighted in yellow is the higher value of spent garnet compared to garnet, because showing that it is sign of contamination from previous blasting activities, and high in chlorine and sodium may increase the possibility of chloride infiltration, which will be proved in RCPT later. And moving on to ICPOES analysis. So these are the results. And from the table here, we can see after mixing spent garnet in concrete, the concentration of barium and chromium decreased compared to before mix because of showing that metallic elements were partially encapsulated within the cementitious matrix. And this value is remain below the limit set by DOE and US EPA, which are 1 mg per liter for barium and 5 mg per liter for chromium. And to conclude, spent garnet is chemically stable and non-hazardous for concrete use, and the finer and smoother particles of spent garnet improve packing density and workability by reducing voids and internal friction. Moving on to workability for fresh concrete, and these are the results. Here we can see for control concrete, it records 0 slump, which is showing that low workability. For garnet mix, it increased the slump to 60 millimeter, showing that medium workability. And the spent garnet mix has the highest slump, which is 80 millimeter, and indicates medium workability also. And this is because of the smoother and rounded shape, which can give better flow to the cement. In conclusion, surface texture strongly influence the workability of concrete, where spent garnet improve workability up to 18 mm slump, which is ideal for easier placement. Next, for mechanical properties, we have compressive strength test and also splitting tensile strength test. For the compressive strength test, from the graph here, we can see the garnet mix has the highest strength at 7 and 28 days. It is because the angular shape and rough surface texture, which improve mechanical interlock. And for the spent garnet, it reduced a bit its strength compared to garnet mix because of the smoother texture and contamination from blasting. But it is still acceptable because it's achieved our target compressive strength, which is at 28 days is 30 MPa. And next is splitting tensile strength test. For splitting tensile strength test, the spent garnet mix has the highest tensile strength, showing that because of the smoother surface, improves stress distribution, which allows slight deformation before failure. And these similar findings reported by Ruslan in 2024, which finest spent abrasive material reduce the interfacial transition zone, which can improve tensile properties. And the last part for result and discussion is durability properties. So for durability properties, we have water exhaustion test and rapid chloride permeability test. So for water exhaustion test, we can see garnet mix has reduced the water exhaustion compared to control because it is attributed to the fillet effect of garnet particles that reduce capillary voids. And for the spent garnet mix, it has the highest water exhaustion due to the rounded shape, high porosity, and surface contamination of spent garnet that can weaken the paste aggregate binding. And these are the formula that I used to calculate the water absorption rate. And I got control and garnet mix has below 5%, which is within the acceptable range. And for the spent garnet mix, it's around 9%, which is considered as high absorption. And based on Galwski in 2023, result under 5% is considered as high quality and dense concrete. Next is rapid chloride permeability test. Same trend was observed for RCPT, where garnet mix has reduced the chloride penetration compared to control concrete. It is because the angular and fillet effect, which can promote fewer capillary pores, which improve matrix interlocking. And the spent garnet has increased its chloride penetration because of the smoother surface that can lead to poor bonding, and it can make ion can transfer easily. So, but even though there is a reduction in chloride penetration for spent garnet and garnet mix, these two mix has categorized under very high permeability because of the charge pass is higher than 4,000 coulomb. So in conclusion, this study investigates the effect of replacing 20% fine aggregate with garnet and spent garnet size and surface texture on the fresh and hardened properties of concrete. To fulfill objective number 1, physical properties has showing that garnet has an angular and rough texture, which can enhance strength and durability, and the spent garnet has a smoother and rounded texture, which can improve workability but increase in porosity. And for chemically side, spent garnet is chemically stable and non-hazardous for concrete use. Therefore, garnet and spent garnet are suitable for partial replacement of fine aggregate in concrete. To fulfill objective number 2, slump test result has showing that garnet and spent garnet can improve workability, which spent garnet give the highest value of slump, which is 80 mm. And to fulfill objective number 3, compressive strength has showed that garnet mix achieve a strength slightly higher than the control and spent garnet, but both garnet and spent garnet mix achieve the target 30 MPa at 28 days. And for tensile strength, Garnet mix achieve a strength higher than the control but lower than the spent garnet because the smoother the surface can improve stress distribution, which allow slightly deformation before failure. And and for durability, water adsorption test has shown that spent garnet recorded higher adsorption, indicates that more porous structure. And for RCPT, Garnet mix had the lowest charge pass, showing better chloride resistance, but still it is considered as very high permeable concrete. Overall, Garnet is more suitable for high strength and durable concrete, while spent garnet is suitable for applications prioritizing workability but needs to adjust the water-cement ratio. And for recommendation, I recommend to extend durability testing by conducting long-term tests such as sulfur attack, carbonation, freeze-thaw to assess real-world durability. The second one is mix improvement by using chemical admixture to enhance strength and workability without increasing water-cement ratio. The third one is large-scale application by testing spent garnet concrete in structural elements such as beam, slabs or columns for industrial validation. And the last one is material optimization by finding the optimal particle size distribution of spent garnet to improve structural and durability performance. With that, that's all for my presentation. Thank you.